dear students, welcome 10th class. Today I'll continue with chemical properties of metals and non-metals. In my previous videos I've discussed with physical properties of metals and characteristic of ionic compounds and the dot structure, remember. Okay, so today I'll continue with chemical properties of metals as well as non-metals. This is another topic, right? Now, the first property, I already told you what is metal. Metal which loses electron. Metals which loses electrons and gains positive charge, that is known as metal. Now, the standard reaction will be given to you. Chemical properties, if you learn those standard reaction, you can frame the formulas yourself. You can frame the reactions yourself, right? Shall I start? Now, first reaction. First reaction, if I say metal reacts with oxygen to form metal oxide. This is known as standard reaction on which you can work out. This is okay. Now suppose if I say metal plus oxygen, any XYZ metal you can take. Suppose if I am taking sodium, sodium plus oxygen, yes, sodium oxide. So, when I am talking about sodium oxide, it should be known to you the formula of sodium oxide. We know the valency of sodium is 1 positive, oxygen is 2 negative. So, what is the formula then? Na2O. This you can already frame because we know that in standard reaction, whenever the metal reacts with oxygen, it always forms metal oxide. Suppose if I say Mg plus O2. We will not take single atom, we will take molecule. We will take molecule because oxygen never exists in the atomic form. Now, Mg plus O2 gives MgO, simple. Yes, next is calcium plus O2 gives calcium oxide. Next, Zn plus O2 gives zinc oxide. This is how, once you know about this, you can able to frame the reactions yourself. We know that metal M for metal reacts with oxygen to form metallic oxide. Yes? Now, next reaction. When metallic oxides reacts with water, reacts with water, it forms magnesium hydroxide. Metal hydroxide. Metal oxide, when reacts with water, it forms metal hydroxide. Clear? Now the thing is, metal hydroxide means we are talking about base. MOH. OH means base. I already told you about this in acid, base and salt chapter. Now, for example, if I say Na2O, that is any oxide you can take, any metal oxide plus water. Yes, student, what is then? MOH, that means simply NaOH, Na1OH minus. So, it will form sodium hydroxide, which is a base. If I am talking about MgO, you should know about all this framing of the formulas because already you have done in your 9th section. I have uploaded one video about all this basic methods of chemistry formation of formulas. So there you can find how to frame these formulas. Clear? So metal oxide, MgO, Mg is metal, plus water. What it forms? MgOH. That means magnesium hydroxide. Clear? If I say aluminium oxide, Al2O3 plus water, it forms aluminium hydroxide, AlOH whole thrice. So these are all the formulas, that is the reactions you can able to frame if you come to know about, yes, the standard reactions. Clear? Now next is, why metals are called basic oxides? 2 mark question. Yes? So what you will write? Metals when reacts with oxygen, it forms metal oxide. Metal oxide when reacts with water, it forms metal hydroxide, which is a base. So 2 marks question, why metals are known as basic oxides are base? Why metals are basic in nature? So you will not write metal reacts with water. No. Metal oxide reacts with water to form base. So you have to mention both the things, that is because they are asking here. They are asking here and this is the answer. So, because metal reacts with oxygen to form metal oxide and metal oxide reacts with water to form metal hydroxide, which is a base. Now the thing is, always that means metals are basic in nature because they are always forming base. So non-metal, come to non-metal. Non-metal plus oxygen forms non-metallic oxide, and when non-metallic oxide reacts with water, it forms acid. Let's go with one example. It forms acid. This is non-metal. Same, but here you will write non-metal. Suppose if I say sulfur plus oxygen gives sulfur dioxide. Simple. Okay? And if sulfur dioxide is reacting with water, is it forming acid? Yes, student. Yes, H2SO3, that is sulfurous acid, not sulfuric. Sulfurous acid, which is an acid. So, whenever metals are there, it forms basic in nature. Metals are always basic in nature and non-metals are acidic in nature. Suppose if the question is, aluminium oxide is basic or acidic? Yes, student. What you will check? Aluminium is what? Aluminium, if it is metal, it is basic in nature. Clear? And if I say HNO3, that is nitric acid, is acidic or basic in nature. So nitrogen, which is a non-metal there. So it is an acidic in nature. Very important 2 marks question may come from this in high order thinking questions in your board. Okay, so jot down in your register, whenever I am talking about metal, it always forms base. Whenever the question is in non-metal, that means we are talking about acids, acidic in nature. Clear? Now next topic, metal reacts with, this is non-metal has been done, and the third reaction, that is, yes student, metals when reacts with acid. Metals when reacts with acid, it forms salt plus hydrogen gas is released with the pop-up sound. Hydrogen gas always releases in pop-up sound and supporter of combustion, burns with pop-up sound, okay, because hydrogen is supporter of combustion. If I am talking about metal, suppose I am talking about sodium plus any acid, HCl or H2SO4 is the main acid which we are using here. Clear? Why HNO3 do not evolve? That is again I'll discuss. Now sodium, now see, hydrogen is released. So you will release hydrogen, we will balance this side. Left is sodium chloride, which is a salt. So sodium chloride. Simple. Simple. What you have to do? Only you have to release hydrogen and the left out. You will frame the formula and write it over here. Suppose if I say Zn plus H2SO4. Zn plus H2SO4. So this hydrogen releases out with a pop-up sound, burns with a pop-up sound, and left is ZnSO4, Zn2, SO4, 2 valency. So 2 cancels, that is ZnSO4. Suppose Mg plus Cl, HCl. What will? Yes student? Yes, MgCl2 plus hydrogen. Calcium plus H2SO4. Calcium sulfate, CaSO4 plus hydrogen. Very easy, nothing is there. The salt and hydrogen gas, this is the standard reaction which you have to learn. Whenever metal reacts with, yes, acids, it always forms salt plus hydrogen. The major acid which will take is HCl and H2SO4. Now, why metals do not evolve hydrogen with nitric acid, that is an acid, but metals do not evolve hydrogen. Very important 2 marks question. Why metals do not evolve hydrogen with HNO3 or nitric acid? Important. Because nitric acid is a strong oxidizing agent. Nitric acid is a strong oxidizing agent, so it oxidizes hydrogen. Which hydrogen is there in HNO3? So HNO3 is a strong oxidizing agent which oxidizes hydrogen to form water and itself reduces to any one of the oxides of nitrogen. Maybe nitrogen dioxide, NO2 or N2O. Okay? NO, N2O or NO. Okay, these are the nitrogen dioxides it will form. Again, I am repeating the answer. Question is, why metal do not evolve hydrogen with HNO3? Because HNO3 is a strong oxidizing agent, it oxidizes hydrogen to form water and itself reduces to any one of the oxides of nitrogen, that is NO, N2O or NO2. Okay, so this is again very important question. Next we'll go with how metals reacts with water. That is very important. Okay, next topic is what happens when metals reacts with water. See, so many metals are there, the reactions are different, but in your syllabus we will talk about those metals which are there in the reactivity series. Already I have discussed about this in chemical equation. What is reactivity series? It is the arrangement of the metals according to its reactivity. The top metals are highly reactive and the least reactive is the last one. Okay, when we move from top to bottom, I have already given you the trick, that is potassium, sodium, professor, SC, muzzle, chap. I have already given the trick in chemical equation. Now the thing is, different metals are there, they perform differently with water. If I'm talking about sodium and potassium, they have one valence in its outermost shell. That means they are very highly reactive. So when potassium and sodium reacts with water, simple, with the cold water, they react very vigorously, so violent, that is exothermic reaction. Highly exothermic, a lot amount of heat energy is released and they catch fire. So sodium and potassium are highly violent in reaction with the water. Reaction, this is the reaction K plus H2O, KOH plus hydrogen. This hydrogen which is releasing is, yes, highly exothermic, because hydrogen is always a supporter of combustion. So here, though it is highly exothermic, which releases out immediately and catches fire. So that is why sodium and potassium, but the reaction is there, simple, with water, KOH plus hydrogen gas. Next metal is calcium. Calcium and magnesium, they have 2 electrons in its outermost shell. Calcium and magnesium, they're not so violent with water because hydrogen gas is not enough to catch fire. But they are, yes, what happens to the hydrogen gas when it is releasing? Now the thing which is very important, the calcium reacts with cold water, not so violent, but the hydrogen gas which is releasing, yes, will be on the surface of the water in the form of bubbles. Hydrogen will be in the form of bubbles on the surface of water, that is metal surface, right? So calcium is not so violent with cold water but starts floating on the surface of water. Next is magnesium. It will react with warm water, not cold. Now calcium, till calcium it is cold water, but in magnesium warm water, and again the hydrogen is, yes, not enough to catch fire, but it will again form the bubbles on the surface of the water. Board question, name 2 metals that forms bubbles on the surface of water. Yes student, calcium and magnesium. Clear? Next is aluminium, zinc and iron. They will react with steam. The formula of steam is again water only, but when they are reacting with steam, they form oxides. Very important, you will not form hydroxides. Clear? They always form oxides and the hydrogen gas will release. Yes, burns with this. Yes, pop-up sound. Now first reaction, this is steam only. What happens when aluminium reacts with water? What you will write? Aluminium not reacts with water, it reacts with steam. Now Al plus H2O, Al2O3 plus H2. Al3, oxygen 2, Al2O3. Zn plus H2O gives ZnO plus hydrogen gas. Next is iron plus H2O gives Fe3o4 plus H2. This is the thing you have to, yes, learn. I'll give you how it has been formed, but this reaction is very, very important because FeO, students write either FeO or Fe2O3, but it is Fe3o4. How it has been formed? First, during this reaction, first step FeO will form, which reacts with Fe2O3 to form Fe3o4. That is, ferrous oxide and ferric oxide reacts together. So that is why this name of this compound is ferro-ferric oxide. Yes, students? Clear? So this is how these will react with water to form oxide layer. and rest of the element from lead to platinum will not react with water. What happens when silver reacts with water? What will write? No reaction takes place. Clear? So this is how metal, all the metal and non-metal I have discussed. These are the properties, chemical properties. From here only this track the question will come. From this extract only. Yes, student. Now next, after reaction with water, the very important topic in metal and non-metal, what are amphoteric oxides? Amphi means both. Amphoteric oxides means when the metal oxide, when reacts with water, when metal oxide reacts with acid as well as base is known as amphoteric oxides. Students used to write metals which are acidic or basic in nature. No, wrong. Metals when reacts with acid as well as base, then it forms the salt and water. So that means it is amphoteric in nature. Clear? All the examples are not there in your syllabus. Only aluminium and zinc is there in the syllabus. And when you are doing amphoteric oxide, you have to give both the reactions, that is with acid as well as with base. For example, aluminium. This is aluminium oxide, Al2O3 plus acid, HCl, hydrochloric acid will form AlCl3 plus water. Clear? And aluminium oxide, here we will take oxide. If we are taking aluminium, we will not release water. Clear? So this is again very important. Now aluminium oxide when reacts with base, which is NaOH, it forms NaLO2 plus water. Sodium aluminate, I have already discussed in acid base about this salt. Again I am repeating here, sodium 1 valency, aluminium 3 valency, 3 plus 1, total they have 4 positive. And there are 2 oxygen, one oxygen is need of 2, another oxygen is need of 2. So these 4 electrons will be transferred to the oxygen. So it will form sodium aluminate. Sodium and aluminium, sodium is highly reactive. That is why sodium is written first. Okay. Next is zinc oxide plus HCl. Zn is another example. Zinc chloride plus water. Here we will take, if we are taking metal, zinc dust can be taken. Question may come, why the zinc dust or iron dust is used in the reaction when it reacts with acids? Okay? Now what happens? Because they increases the surface area. Logic question. Because dust increases the surface area, which increases or speeds up the reaction. Here, zinc oxide plus base, acid, it will form zinc chloride. Zinc oxide plus base forms sodium zincate. Again, sodium 1, zinc 2. Oxygen is need of 4 negative. So, we will take sodium 2, 1, that is sodium and sodium. So, sodium will give 1 electron and zinc will give 2 electrons. So, oxygen will get 4 electrons. So, Na2ZnO2. Clear, students? This is amphoteric. Definitely one question comes from this part. Yes. So next class I'll discuss with metallurgy. Okay, students, then please jot these reactions, learn this. Nothing is there. The standard reaction, once you have come to know, easily you can frame the equations. Clear? So like, share and subscribe. Thank you. God bless you, students.